All right. So this is section 2, topic 6. I'm calling it part 2. On Algebra Nation, there's not a part 2, but remember, I split the lesson into 2 different parts because I wanted to take plenty of time on graphing, and we learned it on a C day, which was short, so then I've kind of made a part 2 for the same topic. But in this part, in the first part, we solve systems of equations by graphing. So you have 2 linear equations. If they're in standard form, you could either find the x-intercept and the y-intercept, graph that way, or you could convert them to slope-intercept form and graph that way. And wherever the 2 lines intersect is your solution, right? So that's one method that you could use to solve systems of equations. Another method that you could use is what we're going to learn today, and it's the substitution method, okay? So we're going to use substitution to solve each system of equations. And in example 1, I have f of x equals 2x minus 1 and g of x equals negative 2x plus 3. And I want to find what the solution is, which remember, solution is what is the ordered pair that they have in common. It could be one ordered pair, it can be an infinite number of ordered pairs, or it could be no ordered pairs, right? We know we could use graphing to find the answer, but I'm not using graphing today. I'm using substitution. So there's 2 ways that I know of that you can use substitution, and the way that I'm going to teach you, students seem to have less of a problem with than the other way, okay? So if you learn how to solve systems in Algebra 1 and you learn the other way and you find that easier, then by all means use that method, okay? The way I teach it is to take your variables and isolate either the x in both of the equations, or isolate the y in both equations, all right? And then go from there. So in this case, these are both written in function notation, function f and function g. And if they're written in function notation, that just means you know this is a function. It would pass the vertical line test, correct? But could we rewrite that as y equals instead of f of x equals? Yeah. And instead of function g of x, I'm just going to write that as y equals negative 2x plus 3. And you don't have to do that, but to me it just makes it less confusing instead of the function notation. All right, in this example, in both of your equations, the y is isolated, correct? So when you start out and in your problem, you have the same variable isolated in both equations, very easy to use substitution, okay? You can find the answer really quickly. So we want to know where your x's are equal and where your y's are equal on both ordered pairs, okay? So we want to know when our x's are equal to each other. So what you do is you take what the y is set equal to in both of those equations, and then you set those parts equal to each other, okay? So I'll set 2x minus 1 equal to negative 2x plus 3. Notice now I only have the variable of x in my equation, okay? So I'm going to solve for x. So in this case, what would I do first? Add 2x. Are there other options besides that? Yeah, there's other things I could do, but that's what I would do first because I like to get my x's on the same side and make them positive if possible. So 2x plus 2x is 4x. Bring down the minus 1. Bring down your equal sign. Negative 2x plus 2x is 0. So we have 0 plus 3 left, or just 3. Then we will Add 1 to both sides. We're trying to isolate the x. So we have, bring down the 4x. Negative 1 plus 1 is 0. We don't need to bring that down. Bring down your equal sign, and 3 plus 1 is 4. Now, we're almost there. We need to divide by 4. So x equals 1. Okay? An ordered pair has an x and a y, right? We have only solved for x. Exactly. If you know x equals 1, then I'm going to substitute that into either of your original equations and solve for y. It does not matter which equation that you choose, you're going to get the same answer. Okay? So I'll just substitute it into y equals 2x minus 1. So I'm going to say now solve for y by substituting x equals 1 into either original equation. So I'll just choose the top one, y equals 2x minus 1. And I already know that x is equal to 1. So instead of this x here, I'll put a 1. So y equals, instead of 2 times x, it'll be 2 times 1 minus 1. Order of operations, we'll do this multiplication first. 2 times 1 is 2. And then 2 minus 1 is 1. So if I were to graph these, they would they would intersect each other at the ordered pair 1, 1. So we need to write our solution as an ordered pair. So x is 1, y is 1. And that's my answer. Bless you. Anybody have a question so far? Now let me just show you, and you don't have to put this in your notes, but the particular class that I'm recording this video in is gonna have an assignment today where they have to solve by graphing and substitution. So let me just show you how I could take this same system and solve by graphing. And it'll be kind of a quick review on the graphing that you have to do today. So I'm gonna take the equation y equals 2x minus 1 and y equals negative 2x plus 3, which we already know the answer is 1, 1, but I'm just gonna show you how you could find it by graphing. So on that first equation, on that top equation, what's my y-intercept? Negative 1. And what is the slope? 2 over 1, right? Rise of 2, a run of 1. So you plot your y-intercept first. So on the y-axis, go down to negative 1. My slope is positive 2. So I have a rise of 2, a run of 1. If I need a positive slope, would I go left 1 or right 1? To the right 1. Rise of 2, run of 1. If I went up 2 and to the left, it would make a negative slope. If I go down 2, I would go to the left. Okay? On the other equation, what's your y-intercept? Positive 3. And your slope is negative 2 over 1. So plot your y-intercept first at positive 3. And your slope is negative 2 over 1. So if I go up 2 to make a negative slope, would I go left or right? Left 1. Up 2, left 1. If I keep going in this direction, I'm not going to run into the other line. So if I go down 2, I would go to the right 1. And what is the ordered pair where these two lines intersect? 1, 1, right? So that is where your solution is, the ordered pair where they intersect. That's the same thing we found when we used substitution to solve it, right? Two different methods, find the same answer. See what I'm saying? Picking up what I'm putting down, smelling what I'm cooking, buying what I'm selling. All right, y'all seem pumped today. Okay, example 2, if there's no other questions on this one. Okay, we have 3x plus 2y equals 2, and negative 3x plus 2y equals negative 4. So on the last problem that we did, both of the equations had the y isolated, correct? In this example, do either of the equations have the y isolated? No. So if we're going to do it the same way, then before we can get started, we have to isolate the same variable in both equations. So we can isolate the y in both of them, or we can isolate the x in both of them. It does not matter which, okay? If I choose to isolate the y's and you choose to isolate the x's, our math is going to look different, but we'll get the same answer in the end, okay? But it doesn't matter which variable you choose. So using substitution is ideal when your equations already have an isolated variable like the last time. You can find the answer just like that. These equations are both in standard form, so we're going to have to do a little more work. The elimination method would be the easiest way to solve this equation, this system. We don't know how to do that yet, all right? We're doing the substitution method. So I'm just going to make myself a note. Choose to isolate either x or y for both equations. Like I said, you cannot isolate the x in one equation and the y in the other. They either both are isolated for y, or you isolate the x in both of them, okay? So I'm just going to isolate the y in both equations. So I'll start with my top equation. 3x plus 2y equals 2. And I want to isolate the y. So what would I do first? Subtract 3x from both sides. So 3x minus 3x is 0. Bring down your positive 2y equals, on the right side is 2 minus 3x. Are those like terms? No, and I'm just going to write it in slope-intercept form. So I would put the term with x first. It is negative, so that'd be negative 3x. 2 is positive, so plus 2. Then what? Divide each term by 2. So 2y divided by 2 is y equals negative 3x divided by 2. I'll just write that as negative 3 halves x. And positive 2 divided by positive 2 is positive 1. So I'm going to write my new system over to the side. So that top equation was in standard form. I basically converted it to slope-intercept form. But it still means the same thing as the top equation. It's just written in a different form now. okay? So now I'm going to take the bottom equation and I'm going to isolate the y in that equation as well. So if I want to get y by itself, what would I do first in this equation? Add 3x. So negative 3x plus 3x is 0. So on the left side, I'm just left with 2y, and it's positive, equals. On the right side, negative 4 plus 3x, those are not like terms, we can't combine them. So I'm going to write the term with the x first, and which is a positive 3x, and 4 is negative, so minus 4. Now what? Divide every term by 2. 2y divided by 2 is y, equals 3 halves. I'm just going to leave it as a fraction. It can't reduce, so just 3 halves x. Negative 4 divided by positive 2 is negative 2. So this bottom equation was converted to slope-intercept form, and it's y equals 3 halves x minus 2. So if I wanted to solve by graphing, now they're in slope-intercept form, I could solve by graphing as well, correct? But in this lesson, we're solving using substitution, so that's what I'm going to do. So we want to know when y equals y and x equals x. So if y equals y, set the side that has the x's on them equal to each other. So that's negative 3 halves x plus 1 equals 3 halves x minus 2. Now, I have x's on the left and x's on the right, so I want to solve for x. So I could add 3 halves x to both sides, and I could do that in this equation. It would be easy, but I'm just going to go ahead and clear the fractions, because I really want y'all to know how to and be pros at clearing the fractions. So what would be a common denominator that I could multiply every term by and it would make my fractions disappear? 2. I've got a denominator of 2, a denominator of 2. So each term, I need to multiply by 2 to clear the fractions. So in the first term, 2 times negative 3 halves x. This 2's in the numerator, this 2's in the denominator, so they're going to cancel each other out. And I'm left with negative 3x. Next term, 2 times positive 1 is positive 2. Don't forget to bring down your equal sign. And the next term, this 2's in the numerator, this 2's in the denominator, so we say they cancel. And leave me with 3x. And then I have 2 times negative 2 is negative 4. I want to get my x's on the same side. What can I do now? What's one thing I could do? Say it again. I could add 4. I could do that. I like to get my x's together first, but you could totally add 4. That's fine. But if I wanted to get my x's together first and keep them positive, what could I do? Add 3x to both sides. Negative 3x plus 3x is 0. So 0 plus 2 is 2 equals, what's 3x plus 3x? Does that cancel? It leaves you with 6x. And then bring down your minus 4. Now what do I do? Add 4 to both sides. Two plus 4 is 6. Bring down your equal sign, bring down your 6x, negative 4 and positive 4 is 0. So now I'm trying to isolate the x. I'll divide both sides by 6, and x equals 1. Is that my final answer? No, because I need an ordered pair. I need x comma y, right? I've only found x. So what should I do now? I gotta substitute it in. You can either substitute it in over here once we convert it to slope-intercept form. You could substitute x equals 1 into either of these equations, or you can go back to your two original equations and substitute it in there. I'll probably go back to the original because there's no fractions, okay? But it doesn't matter. You could do either one. You cannot substitute it into the equation where there's only x's, okay? Because you need to know what y is, and there's no y's in that equation. So I'll just substitute it into 3x plus 2y equals 2. So now find y by substituting x equals 1 into either original equation. And like I said, I'm just going to use that top one, 3x plus 2y equals 2. And I want to know what y is when x equals 1. So wherever I see an x, I'll substitute in a 1. So instead of 3 times x, that'll be 3 times 1 plus 2y equals 2. 3 times 1 is 3 plus 2y equals 2. I want to solve for y, so now I should subtract 3 from both sides of the equation. 3 minus 3 is 0. Bring down 2y equals 2 minus 3 is negative 1. Divide by 2, and y equals negative 1/2. Is it okay if you have a fraction? I mean, is that possible? Yeah, you're going to get fractions sometimes. It's going to happen. So write your solution as an ordered pair. You always do x comma y. So 1 comma negative 1/2. If we were to graph these, we would get the same thing. They would intersect when x is 1 and y is negative 1/2. Anybody have questions? All right, let me do one more. Anybody have a question? All right, example 3. If you have y equals 1 and 4x minus 3y equals 9. Y equals 1, if I graph that, what kind of line would that be, y equals 1? Horizontal line, and it would cross the y-axis at positive 1, right? Well, so don't I already know what y is equal to? Yes. Is it necessary to take 4x minus 3y equals 9 and isolate the y? No, what can I do instead? Yeah, just substitute it. Take this equation, 4x minus 3y equals 9, and wherever I see a y, substitute in a 1, because I already know what y is equal to. So this one's easier than the others. So that's 4x minus 3 times 1 equals 9, which would be 4x minus 3 equals 9. Add add 3 to both sides, and 4x equals 12. Divide by 4, and x equals 3. So the solution, when x is 3, y is 1. Again, that one, it wasn't even necessary to isolate the y on the second equation. You could, that's fine, but you're just creating more work for yourself. You're going to get the same answer. Do y'all feel comfortable with substitution, or do you need another example? You're good? Okay. Let me just show you the graph of this one. Okay? So y equals 1, if there's no x in the equation, it's a horizontal line, correct? And that horizontal line would cross the y-axis at positive 1. So here is positive 1 on my y-axis. Y equals 1 would look like this. The other equation, if I wanted to graph it, I would either need to find the x and the y-intercept, or I could convert it to slope-intercept form. So I'm just going to go ahead and convert it to slope-intercept form because y'all are getting ready to have to graph on your own. So just kind of as a review, 4x minus 3y equals 9. If I want to turn that into slope-intercept form, what should I do first? Subtract 4x. So I have negative 3y, not just 3y, but negative 3y equals negative 4x plus 9. Divide each term by negative 3. So that gives me y equals negative divided by negative is a positive. This is the coefficient of x, so I know it's going to be my slope, so I don't want to turn that into a decimal. So it would be 4/3 x. What's positive 9 divided by negative 3? Negative 3. So my y-intercept is negative 3. My slope is positive 4/3. So a rise of 4, a run of 3, and it's positive. So if I go up 4 units, 1, 2, 3, 4, and I need a positive slope, would I go left 3 or right 3? And right there I can see where they're going to intersect. So they intersect when x is 1, y is 3. Is that what I got when I solved algebraically using substitution? Nope, I got, because I wrote my answer backwards. Why don't y'all tell me? When x is 3, y is 1. Oopsie. I even looked at it and said the wrong thing. When x is 3, y is 1. That's what I got when I solved it algebraically, correct? So I got the right answer, I just said it incorrectly. Anybody have questions on that? Okay. So I will pause the video and then give you your assignment.